All right, and we should be live. Let me just check. And we are, yes, yes, yes. So, right, where did we leave off last time? Well, I was learning data structures and I was talking about how I want to expand the breadth of my knowledge. All right, that's something I'll have to tell you guys about. Right, expanding the breadth of my knowledge more than the depth of a certain topic because these topics I've already done them like 6 months ago. I was doing them and I'm now just repeating them. Like I started doing it in June last year, and then I'm doing the same topic since January this year. And I'm basically just stuck on stacks views. And I mean, I also did trees last time, which I haven't encountered yet. But my goal right now is to expand on the breadth of the topic. Last time we were doing heaps, right? And I practiced a little on my own, did a few lead code questions, and well, I was able to solve the problem of the day on lead code for the first time today. And I had never attempted those questions because I always thought that some of my preparation was lacking, right? Because well, I didn't know graphs or DP, mainly these two things, and I always thought about how well I won't be able to approach the problem because I don't know these. And I don't like that one bit. I don't like that one bit. So that's why I wanted to focus on the breadth of my knowledge. So the step I took for that was I started solving the problem of the day on lead code. I think I'm gonna try doing that every day until I actually find a problem that I cannot solve. Yesterday was a bit of a twist because I thought I solved the problem. I thought it was a string manipulation question, and it turned out it was a two-pass approach, some dominoes toppling over, like that sort of question. And then, but today I had a question and I over optimized the solution, is what I did. Like I was using Boy Moore's voting algorithm, and then I was doing that on like two arrays, and then finding if the frequency of the most character that appears the most is enough. Like it was just something I shouldn't have done because the search space was so small. I could have just brute forced it, and it would have been just as optimal and well more readable, which is what a lot of people are going for. And so what I'm trying to say is stream's current bitrate is lower than the recommended bitrate. Well, I cannot stream at that bitrate probably because of my internet. It's been off all day, and well, I tried to stream in the afternoon, but we had a power cut. Now I ended up streaming at 10 p.m. and I know it's a little late, but we'll figure this out. So what my goal for today is I think I'm gonna expand on that, like learning new data structures, right? We were doing priority queues, and I had some problems last time understanding the heapify method specifically. So I tried asking around, asked a few people, and I couldn't find anyone that would explain it to me on a video call. But well, some guy I know, a colleague of mine, well, from the internship I had last time, he sent me a few videos that I could refer to, and this is one of them. So this is Kunal Kushwaha teaching priority queues, right? I'll just set OBS up here so this works. And we guys, both of us can, well, mostly me, no one's tuned into the stream yet, so mostly me. Well, I can start watching this and see if I can understand what I could not last time from William Facet's playlist. Right, let's see this. Oh wait, what I was also thinking of, something I can do is I can go and ask ChatGPT what I should do. But now I feel like I already know it, but regardless, well, I'm gonna ask ChatGPT what I should do. So we're gonna use the voice one. It's pretty awesome if you haven't seen it yet, check this out. Hey ChatGPT.
Hey there, how's it going?
Right, let me just lower the volume a bit.
No worries, take your time. Let me know if there's anything you need help with.
Right, so I'm an undergrad student. I'm currently preparing data structures and algorithms so I can get into a good company for a job. And well, I had a few questions about my place, like my strategy.
That sounds like a solid plan. That sounds like a solid plan. Preparing for data structures and algorithms is key for tech interviews. What specific questions do you have about your strategy?
Right. So I've been following Striver's A to Z sheet. I don't know if you're familiar with it. And I've been through arrays and strings, bit manipulation, stacks and queues, and like these topics. But what I wanna ask you is if I should first focus on the breadth of my knowledge, like go through the implementation and the theory of graphs, DP, priority queues, union finds, like structures like these, and then go into the depth of these topics, or I should do it the other way around, like I've been doing, like start with arrays, then do all the questions, small, easy, medium, hards, and then go on to like stacks, to easy, medium, hards. What's the best? What should I be doing right now? I've got about, I think, 6 more months to prepare for this, and then I'll be applying to jobs left and right.
It's great that you're dedicating time to prepare. With 6 months to go, you have a good amount of time to cover everything. Here's a balanced approach. 1. Breadth first. Start by covering a wide range of topics, graphs, DP, etc., at a high level. This will help you understand the overall landscape and identify areas of interest or difficulty. 2. Depth later. Once you have a broad understanding, go deeper into each topic. Solve more problems of varying difficulty levels to strengthen your grasp on each concept. 3. Practice regularly. Consistent practice is key. Aim to solve problems daily, gradually increasing the difficulty as you become more comfortable. 4. Mock interviews. As you get closer to your job applications, start doing mock interviews to simulate the real experience and get feedback. Balancing breadth and depth will give you a well-rounded preparation. Keep it up.
Right, I think that's some of what I needed. So I've been trying to learn priority queues right now. And what topic should I go for next?
Priority queues are a great topic to dive into. After priority queues, here are a few topics you might consider. 1. Graphs. Since you mentioned them earlier, understanding graph representations, traversal algorithms, BFS, DFS, and shortest path algorithms, Dijkstra, A-star, can be very useful. 2. Dynamic programming. This is a key area for many technical interviews. Start with understanding the basics and solving classic problems. 3. Trees and binary search trees. Understanding tree structures, traversals, and operations on binary search trees can be very beneficial. 4. Hashing. Understanding hash tables, hash functions, and collision resolution techniques is also important. Focus on understanding the concepts and solving problems related to these topics. You're welcome. If you had any more questions or need further guidance, feel free to ask. Good luck with your preparation.
I think that's it. Thank you. Can you close yourself?
Sure thing.
I'm sorry, but you've hit the daily limit for advanced voice. You can switch to standard now to keep chatting.
Yeah, right. So, like I was saying, the breadth of the topics first, and then depth. Depth.
We'll keep inserting that in a data structure of your choice, whatever you like, linked list, array, or heaps, for example. You don't know about heaps, but we will learn. That's actually the answer. Spoiler alert. Give you 100 numbers. Okay, you store it in your data structure. Okay, now I ask you. I give you 100. Give me the smallest number of all of these 100 numbers. That answer, like, okay, this is the smallest number, should be in constant time. No searching required, nothing. In constant time. How can you do that? Now you will be like, okay, Kunal, let's store it in an array only. But every time you insert an element, sort the array. Every time you insert the element, sort the arrays. For example, I'll be like, okay, insert 3. So initially it's empty. He'll be like insert 8, okay, 8 inserted. Now I'll be like insert 4, okay, 4 inserted. But you can see now array has become unsorted, so I will sort it. Added, insert 2, okay, I added, so on and so forth. Now I'll be like, okay, give me the smallest element. You can now give it in constant time because it's the element at the 0th index. But there's a problem here which is very obvious. Inserting an element is taking O of n time. Why? Because in the worst case scenario, you insert an item, then you have to sort the array or whatever. Or actually not O of n time, O of n log n time. Yeah, O of n log n or O of n squared, whichever sorting algorithm you
No, it's gonna take O n because it's always gonna be sorted.
using, not O of n. So worst case scenario, you're getting like you do either merge sort, whatever, and it's taking extra complexity. Okay, so for inserting an item, it's taking, let's say on an average, O of n log n to insert one item. Okay, that's fine. So the answer that you are getting, like Kunal, you said that I'm storing the data structure, and the main purpose of data structure is to give me the query, which is the conditioned item, which is smallest item or largest item or whatever the condition is, in constant time. This data structure is doing that. But the problem is that inserting an item is taking a lot of time. Now the question arises, okay, this is fine. So this thing is good. We will try to maintain the smallest item at the 0th, the very first index. That is fine. Can you reduce this? Can you reduce this? Can you maybe make it O of log n? To insert one item, it will take log n time. Can you do that? That's the question. Yes. Answer is heap. Using heaps.
This is so boring. I need to
So now
speed this up.
I will
Mm,
build a step by
evolve
using
more.
heaps. In any question, when you're given condition, like okay, you are given 12, n number of movie reviews. I'll show you how the structure is of heap and everything. But yes, okay, that's why we use heap. And when I ask you why we use heap, given a condition or a collection of items, like okay, I give you n items, find me the smallest item. That's the condition. Small.
There's another thing I wanted to show you guys. So I found this. I found this. I should probably. I don't want to get doxxed. A, I'll save this post. B, I will move in like this. Right. Learning DSA from scratch, the ultimate guide 2 years ago. And well, I hope. Right, it's okay. Now look at this. Currently, the market is flooded with new grads on boot campus. You won't like be prepared to work hard and for a while, but when you make it, it's so sweet. Yeah, whatever. DSA resource for Java. Right, this is basically a post where the guy tells you how you're supposed to how you can do DSA from scratch. That's really nice, right? And I was thinking of following this down to a T, right? Learning DSA from scratch, the ultimate guide. DSA can be seen as a three-step process. Learn a language, B, learn a data structure, C, apply it in algorithms. Let's dig in, shall we? So it's a three-step process. Right. Learning is a language is the most asked question. So here's an answer. What language do I pick? Short answer is it depends. The long of it is this. You have primarily three options: C, C++, Java, or Python. What to pick and why? Simply speaking, most programming languages have the same skeleton, there's different ways of doing it. Therefore, they are used in different ways. CPP is a powerful language which gives most of the power in your hands. This includes handling how much power or resource you would demand from a system. What kind of system memory you wish to utilize. If you have a timeline of over a year or more, this is the best option for you. So this is a long learning curve and does take time. It helps a lot in the future, since almost every other language on this list has a feature taken from C++. Lastly, if you wish to join competitive programming, this is the way to go. Java is a language that falls somewhere in the middle. It's not too easy, but not too frustrating. Most service-based companies who are in Asian will prefer Java as a language in many of their projects. Bearing that in mind, if you're aiming for a job in a service-based form, this is the way to go. The learning curve is a bit less than C++, but again, the concepts are quite empowering for a programmer in their career. Python is the kingpin that runs the Wild West. That's IT these days. Python would be the ideal choice if you're on a short deadline, need a job ASAP. The concepts are fewer and the language is less verbose. Resources for C++, which I am doing. First, 2 lectures of Harvard CS50. One of the best explainers of intro to programming I've ever seen. W3 Schools works as a great course material and reference. 3, learn CPP. Frankly, the best place to learn, in my honest opinion. These should be enough for learning C++. Right. So these 3 things for learning C++. And I want to do this. I want to learn C++ from scratch because all I've learned about C++ is like only the stuff I need to do data structures and algorithms. And I don't feel like that's enough at all. Right. I don't want to put that on stream. Close the tab. Let's just wheat math stand stack query. That's trpc. Right, I was watching another like a tutorial on Dan stack query today. What is this? Yeah, this is what I wanted to show you guys. And it's not open. Man. Right, so learn C++, introduction to these tutorials. Programming, programs, language, C++, C++ development. So many like nice things. And I want to learn all of this. All of this. It's gonna be so cool if I get to read all this. What's basic functional files, white space and basic formatting, expressions, functions, return values, void functions, parameters and arguments, local scope, use them for naming collisions, header file, header guards. See, I don't know what header guards are. Debugging, the basic, I have no idea how you debug code. Integrated debugger. See, I have no idea how you do this shit. Fundamental data types. You're supposed to learn debugging before data types? That sounds wrong. The fuck are you gonna debug if you don't even know data types? Can't even declare variables without them. Right, fixed width, integers and size, t, and then constants and strings, literals, string view, operators, precedence and associativity, arithmetic, increment, decrement, comma, conditional, relational, floating point, logical, moved. What do you mean moved? This is honestly so cool. Wow. It's from Feb of this year. Echo the way that C++ prioritizes the evolutions of operator. Why? Why would you say that? Humorous meta comment how the original content ironically demonstrates the very topic it postpones. Oh, okay. Which The humor is dry and subtle, which often gets more appreciation in dev communities. Right. Anyways, and then it's bit manipulation, optional chapter, gonna do that. Scope, duration, and linkage. See, I mean, how is a guy supposed to do actual stuff with C++ if I don't know this shit? Internal linkage, external linkage, control flow, if switch, go to error detection and handling, type conversion, type aliases, type detection, const expression functions, compound types, references, endpointers, null pointers, compound types. I want to ask Chad, man, that's a lot of fucking bro. Like, this is something I want to tell you guys about. Can you see this on the stream? I don't know if you can. I think you can. So this is an application I downloaded that tells me to look away and look far into the distance every 20 minutes. Because I've been, well, my vision's been going very blurry because of the time I've been spending on screen. It's been a lot. It's been a lot of time I've been spending on screen. And we're back. We're back. We're back. We're back. Multi-threading. I don't think I've seen such great tutorials that there are very few people I follow come close to beauty and ease of explanation that you provide in these tutorials. Isn't that nice? Game hacking, chapter 7, stuff sure. I mean, since I feel like some of the chapters so I'm trying to correct me if I'm wrong. 2 weeks and putting 10 plus hours of to get decent understanding. Best thing you do is really finish the series so you have a deep understanding. Go into learning how Windows deals with memory, deep understanding of Windows API, several good books. Basics. This is honestly really nice, but I need to ask ChatGPT if I should be doing this shit. Yeah, okay. I don't need to do all of that. So after this, you're supposed to move on to learning data structures. So what you all must know from a language agnostic point of view, variables, if else, strings, loops, functions, oops, classes, methods, and instances. I know all that shit. We can move on to learning data structures. I'll be listing the most common ones and what approaches are necessary. This is not an exhaustive list. Linked lists, stacks, queues, trees, graphs, heaps, and hash tables. Right. These will allow you to clear any interview or start solving competitive programming problems. Playlist that helped me a lot is William Fissett's video, which I am watching. Tech Interview Handbook, Abdul Bari. Right. HackerRank, LeetCode. Easy problems first, go for medium. Hard problems are better suited for competitive problems only. Use to solve problems is this: set a timer of 20 minutes, read the problem. After 20 minutes, regardless if I had solved the problem or not, reading through the tutorials or looking through on Google for solutions helped me see methods or logics I hadn't thought of before. Form a habit of solving at least 2 problems a day, which helps your mind work every day and allows you to go. Some tips. Getting an error is the rule. The programming running perfect is the exception. This is a mindset which would allow you to get over the hesitation of feeling incompetent and giving up, which is what I've been struggling with a lot lately. Stack Overflow, Reddit, and such other resources are millions of people solving, asking problems. It simply means you're not alone. You can always edit bad code. A blank page is depressing anyway. Write the code once you've got a solution. You can then edit it and make it better. Writing on paper is also a great habit to have. The better programmer keeps going one more time than the person before them. Even the greatest programmer today once didn't know how to declare a variable. Good luck. That is true. It's awesome to know, you know. And that's all I'll need from this learncpu.com. I want to fucking close you off because I don't need you. Cluely, I was looking for careers at Cluely. Are they filled? No, they're not. Forever, 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 forever. Right, let's move on to learning heaps, actual studying part of what we're doing.
Item in constant time. So heaps is used. O of 1 in constant time, you will be able to get that item. If you want to add new items, it will take log of n. How it will take log of n? You don't know yet. I haven't got that. I will teach you. But just know that it will take log of n. How? I will tell you. Okay, so that's very simple. Let's move forward to how heaps work, structure, and why it takes log of n and everything. Okay, so heap structure. Heap is actually stored in the form of an array. Like internally, it's stored in an array. So it will be stored as an array, but it will be represented as a tree. It will be represented as a tree. For example, what I do is that let's say I insert some outputs. Let me show you a diagram. Okay, so here is how it's going to work. I am going to first you how the heap table is stored. Okay, now the diagram you will have here is okay. How are you determining that these values are like when we add? How do you make sure that the smallest item always, or let's say the biggest item always stays in the very first position? We will talk about that later. Okay, right now please don't have these doubts. Right now I am answering the question about the structure of heaps. How is it actually stored? Okay, so here I have skipped 0 to next. Let's say I told you in reality it will be stored as like an array in reality, but we will visualize it like a tree. So for simplicity purpose, I have skipped 0 to next. Leave it empty. Okay, no problem. Say this is my array in which heap is stored 16, 14, 10, 8, 7, 9, 3, 2, 4. So here you see 16, 14, 10, 8, 7, 9, 3, 2, 4. Okay, this is let's say something called, let's say if the question is I give you n numbers, give me the maximum item in constant time. Here the maximum is 16, you will just return the first element, which is 16, so that is correct. It is true. How it is going to be log of n or whatever when we create when we insert an item, that will look at later. Right now let's look at how it is stored actually. Okay. So in the previous example I told you someone asked me minimum item, something, someone asked maximum. Okay. Some of the properties from which what we can see over here. Property number 1 here. It is a complete binary tree. Okay. Represented as a complete binary tree. In reality it is stored in array. It is not stored like a tree in reality. But here you can see I have listed down index number 5 has 7. Here also index number 5 has 7 in the tree. So complete binary, you know what a binary is? Complete binary is every level is full except for the last level, which is the leaf, and the leaf starts from left to right. So I have 2 here, 4 here, next item will here, then here, then here, then here. Okay. Okay. Not a problem. Not an issue. Okay. Complete binary tree. The next thing I want you to notice is that point number 2. Every node that you can see here, since this is a maximum heap, a max heap if you will, because we want maximum item constant time, so it's called max heap. Here you can see every node value is actually greater than, equal to all of its children. For example, 14 will be greater than equal to all of its below it. That's true. Notice something, even though I have the maximum item at the very first index, as you can see over here, maximum item at the very first index, here, you will see that this may not be sorted. And that is okay. That is fine. Not a problem. My concern is that the first element in the array should be maximum, because that's my main problem. I want the maximum item constant time. How we will maintain this? We will tell. I'll tell you later. Okay. Now I have a doubt. Kunal, you are saying it is stored in an array, but how is it represented as a tree? What is the logic behind it? What is the logic behind it? Let's see. So the logic is very simple. Here I can see that the root of the tree is equal to, let's say, if you say I is equal to 1. That is true. That's true. Okay. For any root, sorry, for any node, let's say the parent of that node, let's say if I talk about a node, what is the parent? Parent of a node I is going to be equal to what? You tell me. So let's say if I talk any number. So we talk about index number 5 over here. What is the parent of 5? 2. What is the parent of 4? 2. Okay. What is the parent of 8? 4. What is the parent of 9? 4. Can you see that if the number is I, the index is I, the parent is I divided by 2? What? 9 divided by 2 is integer number 4, because 4.5 is 4. 8 divided by 4 is 4 is 4. So 4 is the parent. Take any example. Index number 7, 7 divided by 2, integer value 3, 6 divided by 3. So the parent index of 6 and 7 is going to be equal to 3. These are indexes of the arrays, okay? Because we are storing it in an array. But how are we representing in a tree? This is how. Parent of every, every index I, the parent is going to be equal to what? I divided by 2. So if I look at the array, I say at index number 6, I have 9. So in this array, who is the parent of index number 6? That's easy. 6 divided by 3. So parent of 9 is 10. And that is true. That's how the array is represented. Similarly, for any node, what is left and right? You can figure this out as well. Let's say if I talk about 3. So index number 3 has left equal to 6. Index number 4 has left equal to 8. Index number 2 has left equal to 4. Index number 1 has left equal to 2. So it's just doubling. Left of any index I is equal to 2 into I. What is right? Index number is 2. Now what is right? Right is equal to 5. Index is 4, right is equal to 9. Index is 3, right is equal to 7. Okay? So similarly, again, we have seen the pattern. Right of any index is equal to 2 into I plus 1. Simple. This answers the question of how the heap is actually represented. In reality, it is stored in an array. We will read it like a tree. It will be more specific, complete, binary tree. And every node will have value greater than or equal to all of its children. The maximum amount you might have already will always get very first context. The rest of the array may not be sorted. But what the rest of the array will have is this condition number 2. Every node greater than or equal to all of its children. And how is this array represented in a tree? These rules. Because of this formula, are there pointers required? Like, when we have node class, we have like node next, node left, node right.
No,
Is that
no
required?
need
No,
for that.
because we are getting the answer directly from formula. No pointers required as well. No pointers. Java has pointers, will get point. Unintended. Alright, okay. Now, one more thing left is what is the height of this binary tree? Complete binary tree, what is the height? For any elements, you know this, we have three playlist videos. Log in. Okay. Height. Log of it. Please don't ask me why. I've covered it in detail in the previous video. If you want to learn about complete binary tree and how the height is logged in and anything, please watch that video. Okay. So, we learned about the motivation behind heaps. We learned about how heaps will be stored in my program, in my computer, in my data structure, how it's represented. We saw that. So it will be stored in an array, but in reality we will look at it like
Because we keep dividing it by
we
2.
will not have
That's
node
why
left,
it's not
node left or node right, but we will use this formula to get those
So
elements
it's
left and
basically
right
number
for
of times
every.
we'll have to divide by 2.
That's why this pointer is not required. Now, few unanswered questions, something that you don't know right now, which is, Kunal, when you add a new item, let's say you add in 37. Okay, so in reality, 16 should be replaced with 37 because you said max heap, in this example, this is max heap. So max heap will always have the highest item at the very first index. And we know that we insert from left to right at the very last level. So let's say for now, index number 10, here I insert 37. Now my heap is becoming long because 37 should come in the place of 16. So Kunal, how would you move this thing up? That's the main question. Question number 1, that's the doubt. Doubt number 2 is that when you have to remove an item, how will it be restructured? And let's say in this case, we're only talking about removing the item at the very first index. That's the whole point, right? If you want to remove anything from the middle or something like that, then just use arrays or normal binary. Why using heaps? Only using heaps when you are confident that you are working with a condition. That's what you're working with. So, removing item, let's say you have to remove, obviously, the first item. So, the maximum item, just give me the maximum item to remove it. So, like, I will remove this, not a problem. But now this area is empty. Now, that is empty. How do I make sure that the next large element is replaced with it? How do I make sure that happens? These are the questions we have. Okay. So, rest of it is clear. Now, let's do heap now. We'll go, say, first item. Let's say insert 9, 10, 14. Let's say 6, 7, 7. Here I know that for every node, value of every node is less than equal to all its children. Makes sense? So value of n is going to be less than, has to be less than all children. Value of 9 has to be less than all of its children. Value of 8 has to be less than all of its children. Right now because 5 is in general. So I know one thing now. I have inserted and you can find parent very easy and by 2. Is the parent of 5 greater than 5? Yes, it is. Okay, swap. So I will swap. 5, 10 will be swapped. In reality, it will be like this.
It's actually n minus 1
Now,
divided by
you
2
have to check it with
for a
the
0 index
other
array.
side also. Do I have to check with 13? Think about it. No, because I know that 13 was actually greater than whatever was over here. So if 5 was smaller than 10, then 5 is automatically going to be smaller than everything that is over here, which is only this one, because it's a complete binary. I think about it now. If I know that, see, in reality, for 10, I know that 13 is greater than 10. Okay, so I'm checking if 5 is less than 10, then of course 5 is also going to be less than 13, hence you don't need to check. Why is 5 going to be less than 13? Because 13 is greater than 10. Makes sense. So I check whether I have 5 over here first, next number 9. I'm going to check, hey, is 5 less than 10? Yes, it is. Now do I check whether 5 is less than 13 or not? No, because I know automatically all numbers below 10 are already greater than 10. So if 5 is less than 10, obviously it's going to be less than what is greater than 10. Very simple mathematics. Okay. Now keep checking till you find that okay, it is not breaking any laws. So I know that now for 5 again check the parent. Now the parent is 8. Is 8 greater than 5? Yes it is. Swap again. 8 5 will be swapped. Now check with the parent again. Now the parent is 7. Is 7 greater than 5? Yes it is. Okay, again swap. And now I'm going to end above. So done. That's it. Problem solved. How you use that? This is known as a heap method. And since you know I'm only checking it once every level, only like once every level. Insert the element. Easy. Try running it. Run it. Now let's check out how to move it. Okay, now we will write from you. This is actually very easy. I am not enjoying. You know, I want to teach class and from you. Heaps is too easy. If someone gives you a question like this is the theory and remove it and make sure this condition is also satisfied, you can do it because you've done that many tutorials. I would say pause this video and think about it. Question is if you want to remove an item. So you all understand how to insert an item. Well, let's say remove the item from the heap. So this is the first item. This will be removed. Now how do you balance this two? How do you make sure that the next smallest item comes out? How do you make sure that false is important? Okay. So you know how when we insert did like from bottom to up, this way we do forward. So just what you have to do is take the last element because that I can get very easy because it's the last and put it as 0 0 first next whatever first next. Remove this. Put it here. 10. Now search for downwards. So start from here. Check what is smaller, left or right. You can get left easy, right easy. 2 into I into I plus 1. Okay. Initially I is equal to say 1. You can take I 0. What is smaller, left or right? You can get left easy, right easy. 2 into I into I plus 1. Okay. Initially I is equal to say 1. You can take I 0 as well. So when I go, I will take array from 0. Not a problem. That will be simple. Very simple. You can take I 0 as well. So when I go, I will take array from 0. Not a problem. That will be simple. Very simple. What will be the values then? If you take array like what will be the whatever you can take from the next also. Now from here, check here. Do I have to check from here? Small swap. No, also. Okay. So I'll check left is smaller, right is smaller. Left is smaller, small swap. Now from here, check here. Do I have to check it from here now from 9 as well? No, I do not. I don't have to check with 9. Okay, because of these conditions. Same reason as I gave previously. Similarly, now from is left smaller or right smaller? Left is smaller, again swap. This will also be. This will be 7. This will be 10. This will be 8. Now left and right. There is no right, so I will not check. Otherwise, I will need exception. Right. So there is no right. Left is left smaller than the current value that I'm checking. No, it's not. Program number. That's it. This is also doing the same thing. Taking it in one at a time. That's why removing will also take log over. Okay. Insertion over done. We saw some as well. Try coding. Try coding. It's very simple. I just told you everything. Told you all the formulas. Try coding from let's say if store it from 0 to etc. And instead of using array, make it like simpler. Use arrays. Arrays is fine. Use arrays. And very simple. Yeah. So log insertion, log insertion, we checked that. We saw the structure, how it's represented. We saw how the tree is represented using these formulas. Or you can start from 0 to as well. You can write formulas for that. I'll write the code. Code link is found in the description below. I will be coding in the browser. You can directly run that web page as well. So the link to the code is in the description. Is anything else remaining? No. Nothing else is remaining. Now it's just simple coding part. Coding part is simple. Most of my videos coding part is 5 minutes. Simple. Okay, after this we will do heap sort and priority in this video. Heap sort is okay, heap sort is easy. I'll tell you right now. So it's so simple. Every time you're moving an item, you know that in heap you are moving the smallest item. Okay, if I remove an item from here right now, it will remove 7, then it will remove 8, then it will remove 9, then it will remove 10, and 11, and 12, and 13, and 14. So keep removing items from the heap and just store it in an array list. What will do? So n item if you remove it will take n in the log heap. N log heap. That heap sort is easy. Nothing in heap sort. Okay. I don't know what you want me to tell you. I feel like teaching, so I got myself as well. And like that's simple. People get confused. They're like, are you sure? Are you sure that it's just this? Nothing else to do that? Yes. What else do you want to say? What else?
Man, he's on. He's fucking on. Like, no, bro, you're not the greatest guy ever to have existed. Just chill the fuck out.
Done. What now? Okay, since we're going to swap a lot of elements, let's say this is an array, let's swap 2 indices, so I'll speak the swap function like this. Private. Okay, since we're going to swap a lot of elements, let's say this is an array, let's swap 2 indices, so I'll speak the swap function like this. Private, not return anything. List dot. Correct traces. Please. It is going to be very shameful for you if I explain to you how this method works. This function is working. Question is swap 2 indices in an array list. It is very shameful if it doesn't make any sense. So okay, fundamental should be clear. That's 1. So parent will become if I equal to 0 means I minus 1.
What method are you constructing?
This is 0,
Get
1,
the
3
parent.
needs to
Oh God.
heap. Up heap. Got it, 22. So when you insert, first we will put the element. I will try to swap it from
Why are you the fuck? Okay, okay. Yeah, got it.
into p is equal to parent of this index. But also, if you are at base dimension, if you are at the 0 index, then it is over. Dot list dot get index, if item at this index, come index exit. So it will be swap, and means if item is swap, parent swap. List dot get parent means if this item is smaller than parent, swap. Index exit. So it will be swap, and then the new element. That's it. Easy. Simple. I showed you the example as well. Very easy. Okay. Similarly,
That's what I did. That's exactly what I did.
list dot get 0 index, and this is that if down heap. Down is very easy. After you have done that, it will be like now do the same thing we did from bottom to up. Now do it from up to bottom. So down heap. Starting from 0 index. Let's make down heap. Get first of all, if left exists. So for example, if left is actually less than list dot size and list dot get minimum dot compare to list dot get left. If this is actually, let's say, if the current min that you have assumed, which is let's say we are over here, if this is actually greater than the left one, so more than 0, then min is going to be equal to left. This is also something I should not be changing. It's very easy. Don't be like Kunal, you are assuming that you know everything. No, shame on you if you think that that's something that needs to be explained. This compared to and stuff. I spent hours in object programming teaching this. And same thing in English also compared to and everything. Okay. If right is less than list dot size and compared to list dot get, if right is greater than 0 means if the right element is heap sort. Heap sort is very easy. Heap sort is a joke. I don't even feel like picking up my pen and paper and explaining. Heap sort is simple. Till the heap is empty, keep removing items and put it in a list. First it will remove 7, okay, 7 will remove. Then it will remove 8, 8 will come over here. Then it will remove 9, 9 will come over here. Then it will remove 10, 10 will come over here. Then it will remove 11, 11 will come over here. So you can see this formula sorts list. Every item you remove takes login time. Total you remove every item is login. Heap sort. That's heap sort. Heap sort. Can you heap sort very easy? Public, let's say I move it in array list of type T. Heap sort throws exception. Array list of type
And
T. It will say list, or it can say data is equal to new array list. While list is not empty. While list is not empty, just keep removing items from the list and add it to data. Please don't ask what the keyword I will use was not. That's it. Keep removing till there is something. Overflow block. How simple is this? Is it not simple? Okay. Now I just add stuff. It's fine. Heap dot insert. If I say 34 or whatever.
bro,
34, that's
this is not
45,
heapify.
22, 89, and 76. And then I'm like, okay,
Not heapify.
remove item from it. System.out.println.
Sure, you can create one from scratch. How can you create a heap in ON time?
It should remove the smallest item, which is 22. Oh, so it should be, okay, throws exception. But it's throwing exception, so it should be declared. 24, simple. What is the next remove? 34 and 45, simple. 34, 45, 34, 45. So easy. Instead of what we can do is heap sort. Array list is equal to heap dot heap sort. This will just give me the sort list and log it. Heap sort. So many typos. Java import, I did not import.
Was going through the same shit I
Okay,
go
that's what
through.
priority is. What do you mean that's what priority is? Are you just going to teach us priority in literally just 10 seconds and say that's what priority is? Exactly. What we just did, that's priority. My priority is as minimum item, so it's minimum item. We did priority queue in this example using heap. That's it. Nothing else I will tell you that is different. That is priority only. But you can also use using linked list. So for example, you can insert it using a linked list. So you can maintain it using a linked list. Let's say I insert 3 first. Then I insert 4. Okay, go. This is how I maintain my priority queue. Problem here is inserting is taking O of time. Good, link this one. O of no. Heap is doing the same thing in O of login. So we will not use this one. I won't code this because we don't have to use it. But you can code it yourself, it's very simple. It uses at the very first head of the link list over here. Then I have 18. Then I want to insert, let's say, 10. So if I want to insert 10, I will check till which item, till which pointer is it less than 10. So you will write till here is less than 10. Okay, go to this pointer by type because we don't jump on the next list. What's the next list? Okay, so you can write items, I will check from here. Is 3 less than 10? Yes, check again. Is 4 less than 10? Yes. Is 8 less than 10? Yes. Is 18 less than 10? No. So check the list. 8. Put it down. This is how I maintain my priority queue. Problem here is inserting is taking
Video voice is echoing, not yours though. Oh yeah, it's because both my mic and the video's mic is on. Let me just turn that off.
time. Priority queue, linked list. Not good. So we will keep using heaps. This is not important. Not good. Linked list one. O of n. No. Heap is doing the same thing in O of login. So we will not use this one. I won't even code this because we don't have to use it. But you can code it yourself. It's very simple. Okay. So that's it. Okay, one more thing I want to teach you, then we'll wrap up and we'll do a question in the next video. Questions. Okay, so let me teach you one thing. Let's say you're given this question. Let's say we learn how to create the heaps and everything. But let's say you're given an unsorted array and you have to.
Right, this is the part I could not get from any video or even like I couldn't get ChatGPT's explanation of it. Let me try this guy and we'll get to know how good he actually is.
Create a max heap from that. Unsorted array is given. Let's say you're given 4, 1, 3, 2, 16, 9, 10, 14, 8, and 7. Remember the fundamentals. We've done the fundamentals. Indices, let's say I start with 1. 1 index, 2, 3, 4, 5, 6, 7, 8, 9, 10. Unsorted array given. Create a max heap from this. Initially, what will it look like? It will look like this. 4, 1, 3, 2, 16, 9, 10, 14, 8, and 7. It will look like this. Now the question is, create a max heap from this. What is max heap property? Every node should be greater than equal to all the children below it. So just try to do that for every single node. That's it. That is it. So for 7, every node below 7 should be greater than equal to 7. There is no node below 7 because it's leaf node. For 8 and for 14. So can I just skip these leaf nodes? Yes, I can. I can just skip these. These as well. I can skip these. I will directly start from 16. So 16 is what? Index number 5. Notice that this index by chance came out to be n divided by 2. n divided by 2, 5. That's not by chance. You know this property of complete binary tree. You know this property of complete binary tree. Why? Why are we starting from n divided by 2? You know this property of complete binary tree. Because we are ignoring all the leaf nodes and the number of leaf nodes in complete binary tree is equal to what? It's around n divided by 2. So why start from n by 2? Because we know we are skipping all the leaf nodes, but we also know n by 2. Now how? How can you prove this? Well, watch the tree playlist, tree video. So start complete binary tree, all are leaf nodes. Well, like, how? How can you prove this? Well, watch the tree playlist, tree video. So start from 5 and then just call down heap on it for every single element. Okay, so obviously I don't have to check the leaf node because there's nothing to check. So for every node from let's say 5 till the root node, so 5, 4, 3, 2, 1 indexes means for index is equal to n by 2 till 1, do down heap of that index. And question solved. For 5 index, do down heap. For 4, do down heap. Why? Because that's what a max heap is. Every node is actually greater than equal to all of its children. But if I ask you the time complexity of this, what will it be? Outer loop is running n by 2 times. Inside it is calling down heap. Down heap is what? Log of n. We know that. So it will be n by 2 log n. But this is actually wrong. That's not the time complexity. We're like, how? It is pretty clear from the formula. Just like with our analysis over here. It is not n by 2 log n. Sorry, n log n. It is not n log n. For 5 index, do down heap. For 4, do down heap. Why? Because that's what a max heap is. Every node is actually greater than equal to all of its children. But if I ask you the time complexity of this, what will it be? Outer loop is running n by 2 times. Inside it is calling down heap. Down heap is what? log of n, we know that. So it will be n by 2 log n. But this is actually wrong. That's not the time complexity. You're like, Kunal, how? It is pretty clear from the formula. Just like with our analysis over here. It is not n by 2 log n. Sorry, n log n. It is not n log n. Then what is it? Let's see. This is going to be a little tricky, but I'll try to explain. For all the nodes that are in level, let's say, 1 above the leaf node, do you know that down heap is taking constant time because there's only one swap? For example, for this one and this one, there's only one swap, so constant time. Okay. And we know that one level above, so if I know that leaf nodes is equal to n by 2, one level above leaf nodes is equal to what? At level number 1. Number of leaf nodes again divided by 2. That's the property of complete binary tree. So n by 4. Level 1. Level 2 will have n by 4 divided by 2, n by 8. Level 3 will have n by 8 divided by 2, n by 16. Similarly, root level will have just 1. Okay. For the leaf nodes, the number of comparisons is 0, 0 time. For one above the level, it is taking, let's say, some constant amount of time c. For level number 2, it is taking
Right. Got myself some steamy milk right here. 14 subs, right? Bro, I have no idea what's happening, but like the last stream I did, it's got more than 50 views. I have no idea how. I mean, that's crazy, bro. It's fucking crazy. I really like that shit. Let me just mute myself and watch this.
now it is level number 2, so it is just 2 above, so 2 into c. This is taking 3 into c. Similarly, for the very last one, it is going to be taking what? How many levels into c? So root level is how many levels in the root? Log of n, so log of n into c. Okay, so what is the total amount of time? N by 4 into c, plus n by 8 into 2c, plus n by 16 into 3c, plus 1 into log nc. So total time comes out to be n divided by 4 into c, plus n divided by 8 into 2c, plus n divided by 16 into 3c, plus 1 into log n, c into log n. Okay, if I just put n by 4 is equal to 2 raised to power k, it will give me what? It will give me, if I just take c common, because I can take c common from everywhere here, take c common, it will be 2 raised to power k plus 1 upon 2 raised to power 0. C 2 raised to power k I can actually take common. C n by 4. C n by 4 common. So this will be 1 plus what? This is actually also 4. This is also again 1 plus 3 common. But actually, let me not just remove it because it will make things confusing. N by 8, 2. So I will just take 1 common, then I will take 2 common here. Divide by, if I remove 4, 2 raised to power 1 or 2 raised to power 0, plus 3 common, 2 raised to power 2, plus 4 common, 2 raised to power 3, plus. In the end, I will say 2 raised to power k because it is log of n. So log of n is equal to what? 2 raised to power k. Just the same thing. So if this is 3, then here I can see this is 3 plus 1, 4, 2, 2 plus 1, 3, 1, 1 plus 1, so k plus 1. Simple. Okay. Now, what I want you to see is that this thing over here, this thing is bounded by a constant. If you take 11th, 12th mathematics, I won't teach 11th, 12th mathematics, but this is actually formula. Sum of x raised to power I to infinity is equal to what? X divided by 1 minus x squared. So sums in mathematics, if you want to check that. Okay, it's divided by a constant. So hence this actually becomes a constant. This actually becomes a constant. My time complexity is O of 2 raised to power k, which is equal to O of n. So it is not O of n log n, it is O of n. That was a little confusing, but I think if I dive too much into the mathematics, it's also something they won't ask you in your interviews that much because it's too heavily focused on maths. But just wanted to mention that a little bit. But yeah, it's very simple. You can use the functions that I've created, just run it in a for loop and just do this thing. Yeah, for I is equal to n by 2 till 1, call down heap on I, that's it. You can make that on your own, I can just literally say what it will be written like. But that's pretty much about it and very easy stuff. Right, cool. Alright, that was basically we started with why, we learned about how it's structured, we learned about like the details, made it from
And
scratch,
that
ran it, learned
fault.
about heap sort, value, or heap to grind basically.
Although this guy is actually pretty good. I really liked this video. I really did. I feel like I want to watch more of these. It was so cool. Well, you should. So if I go to playlists and I go to jobs, this interview prep, question was backtracking, object-oriented programming, DevOps, interviews, podcasts, Java, Sleep, plus programming, pseudocode, oh god, space, no, no, no. Okay, one research questions, yeah, you can spend some time on that. No, no, no. Cycle sort, Amazon, Google questions. I've
This was asked.
given an unsorted integer array, return the smallest missing positive integer. The smallest one time use constant extra space. Maybe if I heapify the array and then I keep taking out. Well, I've got heaps on my mind. You just sorted? It's crazy, bro. Start output for this.
Subscribe and share with your friends so they can also benefit. But please do not skip this video. Amazon at least asks a lot of questions from this pattern. Alright, so let's look at cyclic sort. What is cyclic sort? So we are saying we did let's look at a question. Okay, and then I'll explain. You're given something like this. You have to sort this array. You have to sort this. Selection sort, quick sort, merge sort, whatever. These are like open square, whatever, whatever. But what if I ask you that, hey, I want to solve like this one single plus or one for one. In selection sort, insertion sort, and all these bubbles over here, you are writing two for loops, so it was making n square comparisons, right? Here what we want to do is we'll make n comparisons, sort this in n comparisons. This is a pattern. When given numbers from range 1 to n, use cyclic sort. This is very, very important. Very, 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 very important. This line is very, 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 very important. So some other questions will be like you're given numbers from 1 to n, find the missing number. You're given some unsorted array, find the smallest positive missing number, or something like that. You're given numbers from 1 to n, find the aggregate number. So what do all these things have? 1 to n, 1 to n, 1 to n. This range of 1 to n. Whenever you see a question that has range given from 1 to n, what do you do? Cyclic sort. You remember, okay, Kunal said range given from 1 to n, that's cyclic sort. Kunal said if you're given sorted array, do binary search. So this is why we are saying it's an interview preparation bootcamp. When you are given a question in an interview, it will click to you like this. We did this pattern in Kunal's bootcamp. Okay, so repeat after me. Given range from 1 to n, what do we have to do? Cyclic sort. Okay, let's see how we do cyclic sort. So algorithm, let's say we check the algorithm like how we are running this. So we say something like this only. We say we have something like 3, something like this. We know that. Okay, so imagine what is, this is very important, we're trying to explain what is cyclic sort and how it works. Given that numbers in the array are going from 1 to n, here let's say n is equal to 5, and the array is sorted, in that case, all the numbers are going to be at their correct indices. Okay, all the numbers are going to be at their correct indices. And what are those indices going to be? Let's say if I sort this, let's say index is like this, value minus 1. That's correct. Index is 2, it will contain 3. 4. Why? Because it starts from 0. It will be at the index, that index value will be element minus 1. Why? Because index value starts from 0. So we will solve this particular array. In just one pass we have to solve. In just one single pass I have to solve. So I'm going to start from the very beginning. 3, 5, 2, and 4. 1, 2, 3, 4. So I'm going to start from the very beginning from here. I'm going to check, hey, is 3 at the correct index? You tell me, where should 3 be? If the element contains from 1 to n and index is starting from 0, 3 should be at what index? 3 minus 1? It should be at index number 2. It's going to be like, no. It will become what? 2, 5, 3, 1, 4. Again, I will still over here because it might be possible that what you have swapped, we know that we have swapped 3 to the correct position, but we do not know whether the other number that came to the position of 3, if that is also in the correct position or not. We don't know that. swap with index 2, 3, 1, 4. This again is 5, 4. It will become what? It will become 4, 2, 3, 1, 5. Again, I'll get 4 over here. So I'm like, going to swap it. So I'm like, swap this. This will become 1, 2, 3, 4, 5. Now it's going to be like, is 1 at the correct index? It's going to be like, yes it is, okay, then move forward. Is 2 at the correct index? Yes it is, okay, then move forward. Is 3 at the correct index? Yes it is. Is 4 at the correct index? Yes it is. Is 5 at the correct index? Yes it is. Loop over, answer.
Got
As
it.
simple as that. We know that every unique item is only getting swapped once. Okay, let's talk about the number of comparisons that it's going to make. So we are not implementing I when we are swapping the numbers. Okay, so it might result in more than n iterations of the loop. Okay, but let's check in the worst case, how many swaps is it going to make? How many is remaining while you put it at like, from where you are going to compare it? Here, in this example, what happened is like a verb. That is correct. Once you did, which is equal to 2n minus 1 swaps in voices. And I know that in time complexity we ignore the constants, hence this is big O of n linear. What is the combination we will cover in time complexity? For now, it is going to make at max 2n minus 1 swaps. You already know about time complexity, I covered this in little brief, a little bit more detail in mind research lecture. So you already know what I mean by swaps and how that affects the time and everything. You know that. You have covered this in mind
I
research.
get 2 and minus 1.
1 happened, you made n minus 1 swaps. So n was equal to 5, we made 4 swaps. 1, 2, 3, and 4, that is correct. 4 swaps made. Plus, after that, you made how many other comparisons? 1, 2,
Okay.
3, 4. You are still over here, from where? Total 5 swaps made. Which is equal to 2n minus 1 swaps in voices. And I know that in time complexity we ignore the constants.
Are typing my head? Oh, I'm sorry. I forgot to mute myself.
Hence, this is big O of n linear. What is big O notation? We will cover in time complexity. For now, it is going to make at max 2n minus 1 swap. You already know about time complexity because I covered this in little brief and a little bit more detail in mind research lecture. So you already know what I mean by swap and how that affects the time and everything. You know that. We have covered this in mind research. If you haven't watched mind research, watch it. I hope you are able to understand in worst case how many swaps it's making. Alright, and that's how we swap it. Let's try to code this. That's it with this algorithm. Let's try to code this. After that, we will be doing lots of questions of Amazon and Google. By the way, if you liked it, make sure you like, pause this video, give it a comment. That is the best way to support. Join the Learning in Public initiative. So share your learnings on socials, code and everything. Solve all the Amazon. YouTubers have overhyped this. And in this video, I'll show you clear these interviews like this. It's nothing, literally nothing. Okay, so let's look into it. Let's look at the code base and please make sure you show the support. Okay, first index, and then we are putting it at when I is at the correct index. That's it. Okay, even the hard questions will do. Can say from range 0 to n. Okay, that's fine. Return the only number that is
Yeah, well, I'm trying to think of a solution. So it's got n distinct numbers, and only number is missing in the array. Let me just open this up on LeetCode if I can. 268. Let's open up LeetCode 268. So you don't need result variable return if it's not equal to I last measured numbers of size. Anyways, that's just weird. Given an array nouns containing n distinct numbers, return the only number in the range that is missing from the array. Right, 3012. Okay, so what we're gonna do is, well, I do need to implement cycle sort somehow. So we go here and place it at the right index place. Zero the right index. Okay, so what I'm gonna do is I'm gonna create a new vector because I don't wanna modify the vector I've already been given. And m dot push back -1. Right. And I equal to 0. Nums dot size. If temp, I'm sorry, it's gonna be temp I is equal to index plus 1, right? So it's from 0 to n. It's gonna be from 0 to n, right? Two. And 1 is missing, like 0, 1, 2, 3, and the array size is 3, right? If it's equal to I, well, then you move on. If it's not equal to I, or then you swap temp I and temp I. It's gonna be a while loop. Oh, suppose it's 3, right? Suppose it's going to be temp 0, comma temp. Oh, I would have named that. Let's make it num, which is obviously still confusing, but it's okay. So it's swaps temp side, temp I with temp num, and right, if right, so it's gonna take 3, basically 3. It's minus 1. You can do it in 2. I is not equal to I'm sorry. It's gonna be nums. And yep, I've solved this before. How have I solved this before? Let me just, where's my solutions? Right, you can do that. XOR every number from 0 to n. XOR it with this. Oh, see, these questions can be solved with bit manipulation. It's so nice. Anyways, I'm somehow running out of fucking memory. Right, nums is so if I push back 0, 1, 1, 2, 3. Not equal to I. So it does 0 is 0 times 0 is not equal to minus 1. Swap. Let me go to temp I equal to 3. Swap temp I and temp 3. And it's going to be minus 1. Move forward. Right, it's going to be 0. Swap that. It's going to be 1. Swap that. And I don't get it. I made a big problem. Ouch. And my leg hurts now. Ouch. I don't get. Oh, this isn't. This is always to understand I is equal to I. Ah, did I do an and instead of an or? Oh, no, I did not. Oh, right. It doesn't even reach the second condition. That's all that's happening. Yeah, that should work. The way C++ works. Still didn't work. And temp I is less than temp what size. That's it. No, I want to use cycle sort. Oh, I was looking at this strings and string builder, solve any pattern trick. Introduction to recursion, learning the best way, time and space, bitwise operators, number systems, maths. Question level 1, recursion array questions, pattern questions. Merge sort using recursion, recursion subsets. That's a lot of recursion, bro. N-queens, N9, sudokus, all lead codes. And then you've got oops. And then linked list, stacks and queues, tic-tac-toe, binary trees. Holy shit. Big integer, big decimal. Hash map and hash table, car proven string matching. Actually, that is pretty small for a data structures playlist. It is pretty small. Oh, what the fuck did I close? I don't get it. Why does this fix it? You don't try to swap -1. No, this will always be true unless temp I is equal to I and temp I equal to -1 simultaneously, which is impossible unless I is equal to -1. Infinite loop and get also temp num could cause an outer bounds access. Num is equal to temp dot size. N which is valid input in the problem. I was thinking of that, but then again, what the fuck? Don't try to swap -1. I don't get this condition and I'm feeling so sleepy. I think I'm just gonna go sleep now. I woke up too early today. Does this work? I think the Zord solution is so much prettier. It just is so much prettier to look at and so much easier to understand. Too fast. Subscribe to premium. I don't have money for that kind of thing. Got it. Right, whatever, man. Whatever. Fuck you. Easy ass question. What I'm gonna do is I'm gonna look at. Oh, I'm gonna look at this. Did you watch this? Inserting elements, removing elements, priority queue code.
Alright, welcome back everybody. This is
Man, I don't wanna play with my hamstrings because I'm already pretty cooped up from like the amount of sitting I've been doing on this chair. So I'm gonna end the stream right here and then I'm gonna lay down on my bed, watch this before I go to sleep. What time is it? It's 11:13. Right, that's exactly what I'm gonna do. And if I get distracted, I'm probably gonna go to this tab and watch the Act query and how it works. But well, I don't mind either of those. Thanks for tuning in and thanks Dave for watching my stream, I guess. I'll see you next time. Bye bye.